Hello everyone, welcome to How to Electronics. In previous tutorial, we learned how to set up Dragino LPS8 LoRaWAN gateway with the Things Network server. We also learned about the RA07 LoRaWAN node and the method to send sensor data to the Things Network server using the LoRaWAN gateway. These tutorials cover the method to develop a DIY LoRaWAN end node which can be activated with ABP mode or OTAA mode. For this, we will be using the SX1276 LoRa module and Arduino Pro Mini. The gateway and LoRa node both are configured at the frequency of 868 MHz. The node can publish a Hello World message to the Things Network dashboard. The data being transmitted over the LoRaWAN is encrypted. So, we will learn how to decrypt the data to read the message in readable format. So, if you are a beginner and want to learn about the LoRa and LoRaWAN communication, watch this video till the end. For now, let's begin with this tutorial. Do you want professional PCB like this one that looks so good? Then use the services of Next PCB. You can select the board size, any solder color marks that you want, including something like red and green. You can select the thickness, and the PCB could be from 2 to 32 layers for some more complex design. The finish quality is so good, and if you want better connectivity, you could also select some gold finish for the pads. The ordering process is so easy. Just go to nextpcb.com, then quit now. Insert your design setting, upload your Garbor file, and order now, and receive the PCB in couple of days. The LoRa module that we are using in this project is SX1276 LoRa module. There are various versions of SX1276 from different manufacturers. You can use any of them. In my case, I am using the LoRa module from G Plus IoT. The LoRa should have the frequency of 868 MHz. This is because my LoRaWAN gateway has the same frequency. Most of the LoRa chip doesn't come with the PCB. This means they are not breadboard friendly. To make them breadboard friendly, you can design your own custom PCB and solder LoRa module on them. After soldering the chip on PCB, you can use them with any microcontroller. Let's interface SX1276 LoRa module with Arduino Pro Mini. Now the question is, why you are using Arduino Pro Mini instead of Arduino Uno or Nano? The reason is that LoRa chip is a SPI based chip with 3.3 volt logic level. To get the 3.3 volt logic level, we need to use the Arduino board having 3.3 volt logic. This logic is provided by Arduino Pro Mini board only. Here is a connection diagram for interfacing SX1276 with Arduino board. The connection is fairly simple. Connect all the SPI pin of SX1276 to Arduino SPI pin. We all need to connect at least 2 digital input-output pin of SX1276 to Arduino digital pin. In this circuit, we connected the IO0, IO1 and IO2 pin of LoRa to Arduino digital pin 345. Now, it's time to connect our devices to the Things Network server. So, we'll be registering our end node on the Things Network server. But before that, let's see what is the difference between ABP and OTAA. In ABP activation mode, what happens is that there is a fixed session key for all selected network and is hard-coded on all the end devices. So, the device skips the join procedure, which is simpler. But in case of OTAA mode, what happens is the devices are provisioned with the root keys. This means device address and the session key changes as each new session is established. So according to this, OTAA is better than ABP. This is because of the security reason and the multiple reason which you can read through the official link of the Things Network dashboard. Now, first let's learn about the ABP activation method. So for this, go to the application and then click on add application. Give any name to the application ID and also give any name to application. Then click on create application. Now here go to add end devices. So from here you need to register devices. For that click on manually. Select the frequency plan according to your region. For example, for Europe it's 863 to 870 MHz. Select the LoRaWAN version. It's MAC 1.0.3 according to my gateway. Now in the advanced activation, you need to select the activation method. For now, let's select the activation with ABP. Okay. Then rest of the things there is no need to do. You just need to generate device EUI, device address, apps key, network session key, and then click on register end devices. So the device has been created successfully. So you can see all these network parameters that can be used to establish a LoRaWAN connection with the node. Now for the Arduino part, we will be using a library called LMIC library that is created by the IBM. Now this is the most popular and most secure and advanced library that most of the LoRa providers are using. So you can go through the documentation. The documentations explain how to configure, how to manage the timing, how to activate, all about the downlink and uplink structure. Now go to the Arduino IDE and open an example. So click on TTN ABP. Here is the code. So in this code you can see there is a network session key, app session key, and device EUI and device address. We need to change this parameter. So first let's change the network session key. So copy and paste it here. Now same thing can be done by apps key. So copy this one in the LSB format and then change it here. And similarly we need to change the device address. To do this, just click here and paste it here. So that's it. The configuration part is done. Now we also need to configure the pins. For NNS, RST and DIO0 pin, we need to change the pin over here. In case if you are not using the third pin, then you can use LMIC unused pin here. You need to set up the transmit interval. For now I will be setting it as 30. Now in these lines we need to change the frequency. So where do we get this frequency from? So this frequency you can get from the LoRa router page. So apart from all this, we also need to modify some library. So go to Arduino library folder and then search for Arduino LMIC masters. Inside the SRC folder, go to LMIC and then first we need to change config.h. In this file, you need to make changes. For example, if LMIC debug level is 0, you need to make it 1. You can click on save changes. Now open another file called lorabase.h. So here is the line that needs to be changed. So the line that need to be changed are related to the frequency. The frequency in this code and the frequency here should be same. So make changes to the frequency as per here. So if there is a difference in the frequency, the code might does not work and the LoRa might not communicate with the LoRaWAN server. So after making changes, upload the code to your Arduino Pro Mini board using the USB to TTL converter. Now open the serial monitor. So you can see starting packet queue and you'll be getting the following message once all the transmission is done and all the packets and payloads are transmitted. So where to view this part? So go to the Things Network dashboard and in the live data you can see the message has been received but the message is in encrypted format. So how to decrypt this? So go to the payload formatters and from here you need to select formatter type as JavaScript and then make changes here. Put this Java code to decode. Okay, now go to the messaging again. Now go to the live data again. Now you can see the encrypted message had been decrypted and the hello world is seen here. So when you click this hello world, you will need to know about all the time, format, date, packet length, size, and all the details of this message. So this is how the message can be decrypted, and this is how you can do the transmission in ABP mode. Now let's see about the transmission via OTA activation method. Now again add end devices. Here again select manually. Select the frequency plan here. Same thing that I did earlier. Same LoRaWAN version, and in the advanced methods this time select OTA, that is over the air activation. Here the parameters are different: generate device EUI, app key, and the app EUI. Now again click on register end devices. So the device has been registered successfully. So we have app EUI, dev EUI, and app key. This all will be used in this code part. So we just need to copy this and paste it on the example code. So again go to the file, examples, and the LMIC example code as OTAA. So here is the code. You need to change app EUI, dev EUI, and app key. Now go to the app EUI, and this should be changed to LSP format. Similarly, we also need to make changes to device EUI. This should also be in LSP format. So copy it and change it here. Now there is a app key. The app key should be in MSB format. Copy it and paste it here. So that's it. Again make changes to the pin part. I mean, you need to make changes as per your Arduino circuit. Now again go to the tools, again select Arduino Pro Mini, COM port, and upload the code. So once the code is uploaded, again open serial monitor. So this time again you can see starting, packet is queued, and EV joining. So it means the node has joined the network. So when you go to the Things Network dashboard, you can see the connection has been established and the dashboard has started receiving the message. But again it is in encrypted format. So same thing we need to go. We need to go to the payload formatter, and in the payload formatter we need to keep the same JavaScript code. So the JavaScript code will decode the message from the encrypted format. So in the live data, you can now see the decrypted message is available. It means the data which was in encrypted format has been decrypted, and we can see the hello world packet has been received. So this is how you can transmit the data with OTAA activation method. The written tutorial for this both method is available in the article of How to Electronics. You can follow the website articles. The website articles also contains the information about the LoRa module, PCB, Gerber file, the method to activate, the source code, the program, and also the circuit diagram connections. In case if you are feeling any trouble, you can simply comment down in the comment section below. Thank you so much for watching. See you in the next video.